would say, this assumption, whether it can be used to write a smart contract. So, how many of people here heard about Bitcoin script? Script. Okay, cool. So basically, that's when Satoshi first released Bitcoin, even 0.1. You can, if you look at his post on Bitcoin Talk, it says, okay, so when I release this Bitcoin, I'm not only trying to only do money transfer. There's only one type of transaction. I'm also putting the so-called scripting language inside Bitcoin, so you can do any arbitrary kind of contracts you can think of. For example, easiest one we can think of is let's say multi-sig. So basically, not only you have one signature, you can have arbitrary setup. Let's say, or you require, I don't know, 2 out of 5 people to sign to move these coins, and also you can do multi-party computation. Basically, any arbitrary kind of computation you can do within Bitcoin network. So the way to do it is like this. So the Bitcoin model is the so-called UTXO model. So basically, each Bitcoin is actually, you can think of as like a physical coin. So the only difference is with the physical coin, for every coin, there's a lock. The coin is locked. So basically, that's the so-called spending condition. So the only way you move this coin is by, you kind of have to find a key. The key, if you can open the lock, then you can move the coin. So the so-called, that's how the scripting plays. So how do you specify the locking and unlocking it through this language called Bitcoin script. So basically, it's like a very low level, kind of like a machine language. You can do a pretty basic, like arithmetic or crypto or signature verification. So it's designed after a language called Force. It's kind of like esoteric. I think some people, I've never heard about it before Bitcoin. So I've been programming like 15 years. I've never heard about it, but it's kind of like a special language. It's called a stack-based language. So I can show you something. I think, by the way, I think mostly this talk is going to be accompanied by demos. So I've been pretty, like, I want to show this can actually be done. How do you program? Because the title is how do you program smart contract on Bitcoin. So pretty much, along the talk, I will get some demos going. So if you have any questions, just feel free to stop me anytime and ask questions. So, for example, here I have this site. Basically, it's so for this project, there are mainly 2 parts. The first one, the language itself is part. So basically, I have a language called script that it's like one layer on top of abstraction on top of script. So I'm first going to show script, and then why, kind of like motivate why we don't want to have some kind of tools. Let's say I have this idea I'm going to cover later, but for now you can think of, I can write some script inside it. Let's say I have I can put some number. This is like a opcode, like instruction. This instruction basically because it's stack based. So what does it mean is it just put the number 1 into the stack. So let's say if I write, play with it. Okay. So okay. I put something here. Let's say 1. Let's say okay. So now it's get going. I can run. Okay. If I run, let's say can you see from behind? I can put it a lot bigger. So this just give you a feeling of what the script should look like. For example, here, this is the locking script. This is like the coin. You put a lock into the coin. So the way how you move the coin is you have to find the key, which is the unlocking part. So both this part are expressed using script. So this is almost the simple. That's like a hello world of script. So basically, here what it says is I have to find a number. If I put, so the way the lock is And the key combines together is you put this, you combine these two together and you run through it. So if the final result gives you true, then you say, okay, you can move the coin. Otherwise, you cannot. So for example, here, what did it say? So basically, you want to find a number. This instruction basically compares the. Okay, so I'm going to run through and then show this. So for example, you say, okay, op1, this pretty much says put number 1 onto the stack. That's what it does. And then okay, another op1 here. And then the third one is, what does this do? So basically, this takes the top two elements and compare. If they are equal, it will return true. If not, it will return false. So of course, we can see here, because 1 equals to 1, this will return true. That means, okay, now I can spend the coins. So basically, if you put the locking condition as this, you can spend using this number. So let's say, just give another counter example here. And let's say put it 2. What will happen? Any guess? If I put 2? Yeah. So if you can run through it, yeah, basically because it will compare the top 2 elements on the stack. It's not equal, so it will false. So actually you can write any arbitrary complex contracts, because what is the smart contract? The way I think of it is like there's some condition you have to satisfy, and then if you move, then the funds, in terms of Bitcoin, they can move. So basically, it's like conditional payments. You can think of the easiest way, but it's not run on a laptop, not run on some server. It is enforced by the Bitcoin network, which are run by the miners. So that's a critical difference between using what I call smart contract here versus like a normal any computer program. So in principle, you can write any arbitrary complex contract in this language, but here's some problem. So I'll give you one simple example here. Basically, there's a function. Basically, I call it Ackermann. Basically, you want to compute some number, right? This is like a math function. You want to compute some number, and if it turns out, if you want to write this simple, I think the function is not very complex. I think if you can write in JavaScript or something, it may take you like, I don't know, 5 or 6 lines. That's it. And it's basic addition or multiplication. But if you write it into script, if you expand it out, it looks like something like this. So I don't know about you guys. It's like it looks very development friendly, or to me it's more like techno. That's the way I can say it's definitely not something I want to program in daily. Right? I would rather prefer something that's more similar to the mainstream like programming, like Python or JavaScript, whatever you guys write. Something high level. So basically, we need this abstraction layer. Basically, the underlying machine, it's like Bitcoin machine can do everything. It's like analogy I want to put is like you have a machine language now. You can actually compute. You can actually code, let's say your MacBook in all the Intel or ARM instruction. You can do that, but nobody today is going to do it. It's not efficient, right? So we need some kind of tool that can help you develop this in this script, but we don't want to directly handle it. So that's why we have the script. We want to build some abstraction, high-level language, so-called high-level language, to make developers' task easier. But also not only the language itself, but also need it's like developing any other language, right? You want all the toolings like IDE, and you also have libraries. You also have testing framework. You also have SDKs. Basically, everything around is like any other mainstream network programming languages. So to give you a sense here, so basically on the left, I show kind of like a very one of the simple examples there. Basically, it takes take 2 numbers, and then there's a function that can sum these 2. So that's it. So after you compile it down, and then it looks like something like this on the right, right? So now you can kind of get a sense. I'm going to jump into more details later, but now you just at first glance, right? You kind of feel, I don't know, sure you, but you hopefully you are more comfortable programming something on the left than writing something on the right, right? So this is the Bitcoin native script, and this is the S script. Okay. Any questions so far? Script? All good? Okay, so I'm going to give some like a walk through some examples, and then I can also show the idea I have so far, so we can just get a sense how this language looks like, and also introduce some, I think from the outside looks like very similar to if you guys are programming, say JavaScript or Solidity. Any guys programming JavaScript? I think everybody here, or even Tom. So he's still learning JavaScript. So and Solidity. How many guys have you heard about Solidity? This not programming. I know we have all been there, but we don't usually say it in public. But yeah, I was playing it with it one time. So. So basically here is the basic structure for the smart contract. Basically it looks like JavaScript or like Solidity. This basically is like an object-oriented programming language. So on the highest level, you have the so-called contract. So instead of class, it's like, think of like a class in mainstream programming language, like JavaScript, C++ or Python. You have this is the highest level, the contract. That basically means one type of contract. It's like a represent one type of contract. Let's say when you move a coin, when you send some Bitcoin to somebody else, it's the so-called public key hash, pay to public hash. So basically that's one, you can think of it as one type of contract. So basically you also have like any other class, object-oriented class, you have internal member variables, and also you have a constructor, and also you have a member function as well. So the only thing I think that's special here is the so-called public function. So what is the public function here? So basically, when the contract, right, you have two parts. You can have the locking part, and you have the unlocking part. The locking part corresponds to the public function. So basically, that's something. Why is it? You think of you deploy a contract on chain, right, on Bitcoin, and then you can interact with the contract. How you interact with it? You call its public function. Okay. So this body, you can think of whatever within the body of the public function, it goes into the locking script. Okay. And whatever is parameter you're taking in inputs, this will be your key. You think of the body of the public function will be the locking part. And how do you unlock it? You give these right parameters. Okay, that's number one we have to remember. So basically, public function is like the main. It's like a main function in C++, or it's the entry point for the whole contract. How do you interact with it from external? So another thing I have here is required. So if you have been from Solidity, you also have this keyword. So basically, it's more like it's a so-called assertion in a lot of other mainstream languages. So basically, what does it do? So it takes a Boolean expression. So basically, it takes a value, true or false. If it's true, it's good. Then nothing happens. You just pass, keep going. So if it's false, then you will cause the whole thing to fail. So basically, it says, okay, here, for example, here you have to give this x, which has to be equal to this y. No, y has to be given to the equal to the x. Otherwise, this thing will fail, and that's the only condition to spend it. So I think enough theory. I think I'm going to show some demos here, so hopefully I can explain more. So I have the previously I mentioned program here. So basically, I call it equal. It's a demo program. Equal. Oh, basically, before I do that, this is that's the online ID I developed. Basically, for ease of development, you can just you don't have to install anything. Just go to, I showed the URL later, but it's basically script.studio. So if you go to script.studio, you can launch this. You don't have to install anything. You can immediately start playing, and you have the editor part. It's like almost like you guys use Visual Studio Code, right? Like a VS Code. Look at that thing. So basically, you have all the open files. You have the editor, and also you have the place where the script is showing. Oh, sorry. And also you have there's another place you can, it's like a debugger. So you want to walk through step by step or function by function, line by line. You can also do that. So in this example, let me enlarge it. So basically this contract is saying, okay, first I need to, after I write it, right, of course, and then I have to compile it. Okay. Oops. I don't know. Is that Wi-Fi? Don't worry about it. I think I just used a local one. So basically, first, okay, that's good. And you can see as after I click compile, it will show whatever has been compiled to. So it looks like something like this. So even for this simple way, it looks like not something I think mainstream developers want to work with. At least even for me, I read this thing, I don't want to code this thing ever. So yeah, I read this thing. I mean, at the beginning, it's for myself. You know, it's useful. I don't want to write this thing. So after we compile, so basically this is like a template you can have. You can look like it's not elegant. So how I do it? Now I have this contract template, which then I can initiate it. Right? I can give it plug in some numbers, and then it will actually can become something tangible. I can deploy on the Bitcoin network. So because you can see here, there's still something that's only initialized because it has some variables. I cannot put this. This everything else is already script, but except this symbol here, right? Because I have to give it some number. It's like any other object, right? So after this is only like a class. I have to give it parameters to initialize the class, so it can become an object, right? So it's the similar concept here. So let's say I give a number here. Anything? 42, maybe. Okay, and now, because this is a hex, so this is actually 42 in hex, because usually when you talk DOV, especially when you can push a large, in one operation you can push a large number into it, usually it's hexes, easier to see. So once I initialize it, actually now I can take this thing and put it in my transaction and send it to the broadcaster network. And then it can be the coin, whatever is there, it can lock up there. So how to unlock it, as I previously mentioned, you call the public function, right? So you come here, now your contract is deployed here. You can think of, okay, now I have to give a number. And guess what number though? How do I spend the coin? So based on the, anybody guess?
42.
42, yeah. Let's see, try it. It's the magic number. Let's say what does it work? Okay, let's just call it equal. Okay, congrats, you just win some lottery. You can actually spend the coins. So if you give the right number, that's a good thing about it. So this is a basic workflow. So you can compile it, and then you can initialize it. You plug in this is like a template for any kind of. Basically, this says is the contract has some magic number, and if you know this number, you can plug in and you can unlock it. So the initialize, you can initialize the object, and then you can call its number, call its public function, which is equal there. And also I can show something here too. You can basically not only, you can also say you want to debug it. Basically you can run each by opcode. You can say, okay, now the stack is changing here. And also you can debug line by line. You can walk through it, and you can also reset it. So basically that's kind of like a hello world of this language. Does it make sense so far? Any questions so far? Okay. So let's just keep going. So, okay, I'm going to skip this because we just talked about it. Okay, here's an interesting thing. So, one reason people are saying, oh, script is very limited. You hear people always saying it's not Turing complete. And we have a lot of other chains that claim they're superior because, oh, we are Turing complete. We can write any kind of arbitrary thing. So that's a big critique. I think a lot of time people criticize Bitcoin is because I would say a lack of understanding. So one big criticism is oh, it's not Turing complete. Why? Because you cannot have loops, right? Because you can do usually when you have any high-level language, you can do sequential execution, you can do branching, right? And also one almost have sure thing you want to have is a way to loop things, right? So actually, I'm going to show some way. Actually, you can do loops, but it's not the conventional way. Is a little bit different than probably what you have seen in other languages. Okay, and also there's a reason for that. So, for example, here I want to compute whatever is inside this curly braces. Let's say this statement I want to write, let's say 3 times, right? How do I do it? How can I do it? If in other language, what usually want the loops, if you can compile down to machine code, what it does is the function body, okay, can get compiled, and then when you run to the end, you check the condition. So if some condition is met, you jump back to the head of it. So it's through the jumping statement, right? But because in Bitcoin, in script, if you look at all the script or code, you don't have the jumping. For some very good reason. So if you have ever heard about some other chains always constantly get hacked, DAO hack or parity hack, you can see why when Satoshi first designed it, it basically is a feature. It's not a bug. Basically, you think about it, right? So if you have some coins that are locked in some script that can have loops, well, what's the problem there? Any problem?
Infinite loops.
Yeah, you can, right? And there's no easy way to, because usually for any program, if you can do loops, there's no. I think it's not easy way to detect whether you were ever hot, right? It's like a very famous computer science theoretical, the hot problem. You don't know whether you're hot or not. The only way to find out is to write. And what if you're not? Then the whole network hots down, right? You don't ever want to have the whole network because somebody writes a program, maybe intentionally or unintentionally, just bring the whole thing down, right? That's why it never has the looping function built in. But if the underlying script doesn't allow you to loop, doesn't mean you cannot do loop on top of it, right? It's like saying, okay, how do you do multiplication? Because, I mean, let's say how do you compute 42 times 1,000? I mean, by definition, right, you can add 42 by 1,000 times. That's by definition. But you can do that way, but you can have some other more compact ways to do it, right? So same here. So basically what I'm saying is, even the underlying fundamental script, they don't have the direct looping construct, but that's something you can construct on top of it. There's nothing stopping you to. So the simple way would be, like, let's say even for your CPU, right? It doesn't have loop. CPUs also doesn't have loop. The way we program in high level languages to build some high level abstraction on top of it, so you can have loops. But actually, if you think about it, you don't have to have loops. Actually, you can write everything sequentially, right? So that's it. So if you look at even from a CPU's perspective, CPU doesn't have loops. It always runs the code one iteration at a time, and then once finished iteration 1, it goes to the next iteration. There's no loop. The same thing. You can apply the principle. It's called usually in the compiler or language field, it's called unroll the loops. So basically, you just expand whatever the CPU is doing, and then you just lay it out in that way. So, for example, you want to compute. Let's say you want to double a number, right? Actually, you can if you want to double it 10 times, what do? You can write the same thing, right? 10 times. What if you want to write it? What if you want to double it 100 times or 1 million times? I mean, theoretically, you can just code it such that you just put the instruction, the statement, 1 million times, right? But usually that's not very efficient, right? Who here wants to write like 1 million lines same repeat? It's not so. So that's why I have syntax on the left. So basically, it's called a loop statement, which that's something kind of like a little bit out of nowhere. But if you think about it, basically, you can write a script in this way, but it's not efficient. So that's why it collapses into the more complex form on the left. So basically, you have a loop, and then you give it some number, and then whatever you want, whatever the loop you want to do, you just put into the loop, the body of the loop. So for example, here 3, right? I'll go show some example here. So I think this one is one of the existing interesting examples here. So for example, I have a contract here. I do some simple loops. So basically, I put a number. If you can read about it. So basically, I want to sum it. I want to compute 3 times of it, and then I want to give the secret, the key, such that 3 times of the number I initialize with, right? So for example, I can go, let's say I can compile it again. I can initialize, put some number, any number, 12, say. Okay, so then again, it's now compiled down to Bitcoin script, native script, and then when I want to spend the coins, I have to give it the secret, the key, right? Which in this case is no surprise, 36, right? So now I'm good, and I want to show you because 3. I mean, if it's just 3, in principle, you can actually write it 3 times. It's not a big deal, right? So think about what if you go to, let's say, play with something bigger, 30, let's say. So you can keep an eye on this blocking script. So if I compile it, right? So if it's 30, now you can kind of get a sense what the script is doing. I mean, under the hood, you can see, okay, actually this same code is repeated 30 times here. So again, imagine this, let's say 300. I don't know how my browser is okay with this, but let's try just play with it. Okay, it works. So now, if you look at this is like a 300 times repeated. So hopefully this construct is much developer friendly. Okay. Any question here? I think that's what usually there's some BTC guys that come and ask me questions this time. So if you are here, identify yourself. But if you're not, you can also ask me questions. Anybody has? Okay, Brendan.
Can you do parameterized loops, like passing in a variable as the number of times?
Okay, actually no. So think about this is something that's because this is something that's statically compiled. So you have to know it compile time. Because what if I can use, what do you suggest? You can say upper bound is a variable. The problem then, again, right? What if the number is like, because in runtime, you don't know, right? And especially the runtime parameter can depend on the user input. So it can be any number you can think of. So that's one way to say, because if it's runtime dependent, and then you can never say you can halt, right?
Yeah, you can't. You definitely can't. I wonder though, could you put like restrictions on your input? So like you say, okay, this number can never be more than, I don't know, 100 or something.
Oh, you can check that, but that's one reason you cannot have a variable. The other reason is you have this, because this thing is expanded. It's just a syntax sure, right? You have to, at the compile time, the compiler has to know how many times you are going to run. It's like upper bound. This is not exact, but you can say this is the upper bound. So I can show you something. I think that's make even more sense. So, for example, right, you want to say, I want to find some, I don't know, that you want to find some, I don't know, maybe find some common denominators for two integers, or you want to find some, I don't know, you want to have a lot of loops. Right then, the problem is because the way we do loops is to just repeat whatever in the body x number of times, right? So it has to know how many times you want to have the body repeated. You cannot say this is something you can determine, because think about it, right? So if you don't, because when you compile down this thing, you're going to send to the network. Then no matter how many loops, how many times you repeat there is there. You cannot then use something off chain to change it. So there, think about the whatever is in here is like an upper bound. So another analogy I give is it's like almost like your gas limit, right? So you want to know how many times you want, maximum number of times you run before you are out.
Yeah.
So
I think what I was getting at was you could maybe, with the right language, maybe you could guess what is the upper bound of a parameter that you would pass in. But I think I understand what you're saying here. What you're saying is that you set the upper bound yourself, and then if you have conditions that you need to get out of the loop,
yes,
you write those yourself as well.
Yeah, yes.
Yeah.
So the language itself, you only give you the primitive to choose, right?
Yes.
So you can only say, okay, I have this looping primitive, and then how do you do it? How do you make it sure you're not? Because the problem is if you set it too small, you can fail, right? For example, you compute some number which can require 100 times iteration, but you only put 50, you will fail, right?
Yeah.
Will not give the result. But the problem is if it's too large, we all know, right? Because this thing is going to repeat that times, and at least for the current fee, the longer script you have, right, the more fees you pay, and nobody wants to pay extra.
So in that example right there, we have the conditional loop. What is going to be emitted? The way I look at this is, you're writing in a higher level language something that will be emitted out into a lower level language, and it has to be emitted before it's stored on the blockchain.
Yes,
So you only get one shot. So how does that get expressed? That example right there get expressed?
this one or this one?
Are the conditional loop there? That one right there.
Yeah.
What I'm curious about is when it's emitted, are the ifs nested or are the ifs in line? I'm thinking it's going to be one after another, one if after another.
Yes.
So,
it's not going
so
to
if
be,
you had, instead of 3, if you had 30, and if whatever condition you had there was met on the 5th time, then you would be making the same test.
yes, but you would never get into the if.
Right.
You see what I mean?
So is there a way to do it? Yes, you would never get into the if,
Yes.
but you'd have to not get into the if for every iteration that you did not need. Does that make sense?
Yes, I think that's you are
Can
talking
you-
about
can
break.
you have
Break, right?
Okay, break, yes.
So that's one way to do it.
Okay.
You see, you just set like a flag, right? So okay, if you already hit a condition, you just set it true, and then at the beginning of each loop, you test, right? So that's actually what the CPU does. If you look at the lowest level, when the CPU doesn't have loops and check condition, it always when you say, even for some compilers even implement break in this way. That's one way to implement it. Of course, you can have jumping conditions, jumping instructions. But if you don't have jump, how do? You just check whether this you have finished whether your break condition has been hit, right? If it's been hit, you just set this kind of like a variable, and then before you do every iteration, you check it.
Do you have an example of that in your demo?
Yeah, I can.
I'm just curious how that gets expressed.
Yeah, I can. What do you
Because
want?
at the end of the day, both of those examples have to be emitted into the
Yes.
script.
There's nothing. Everything has to be already translated to script, because
Yes.
otherwise you send to miner, they're going to reject it, right? So every year before you broadcast, everything is already script, because the miners, the Bitcoin node only understands script. You cannot send it like a variable or anything. So I think I never tried, but I think it can work. Let's request it. Let's just see this. How this goes. Let's see. put something here. Let's say, for example, this is this old syntax. Okay. Let's sum this up. This is no.
Next thing I'm going to wish is that you could if you could do a pretty on the locking script.
Say it again.
Well, you know, you can beautify or
Oh yeah,
the indentation on the It's hard to follow with that.
Yeah, this is kind of unintentional. I love it. Obviously, my.
Well, it makes the point. Yeah, I agree.
Yes.
Who wants to deal with that?
I'm a little bit biased in that, but yeah, you got me.
I agree.
That's the same. You got me. It's like you are demoing some Apple product and then you are putting Windows. So it's not. You better make it Office not slow, right? I mean. This never stops. Let's keep doubling. Okay. So check. This should be good. Let's go. Okay, this it compiles. You want to see the body, right? So I think this is a little bit messy here.
Yeah, it is messy. It's hard to see. I'd have to spend time on that.
Yeah, it's some.
What I was really trying to hit on is whether the ifs were nested. If you could control whether the ifs are nested or whether they actually end up the
I
same
think it's
if on every single iteration.
after another. It's not nested because you think about the logic, right? That means you are doing it not one every time you into one more nesting there. You are doing it one after another.
Yeah.
You are not nesting. If you're nesting, you have to put the if keep going. And you have to do that. The compiler only take the whole thing and then wrap it up and repeat this many times. Okay. Another. Okay.
Can you do recursion? Would you ever want to do recursion?
That's another thing. Recursion is almost like a loop, right? If you think about it, even for some languages, they do loops in recursion. For example, a lot of functional language. If you heard about it, like Haskell. There's no loop. It's loop is through recursion. So these two are more like a functional equivalent. So when I say you cannot have any arbitrary looping, that also means you cannot have any arbitrary recursion. But also, recursion can be converted to non-recursive version. So whatever recursion you have, you can also, there's some way. I think. Again, it's like a function is similar to loop. So the problem, okay, let's assume I put recursion here. What will happen? You have the same thing. If I put you can have any arbitrary loop. You may never stop, right? So the way, if you have some loop, recursion, the way how you do it for now, at least for now, you have to get an iterative version. And then, because you can express this in iterative version, right? That's how you handle it. Does that make sense? So basically, you can think of functionally, the looping is obviously equivalent to recursion.
So on that, didn't Craig say at one point in time that nChain was working on the ability to effectively call a script from a different transaction?
From different transaction. I think that's something not within script itself. Because think about it, right? If you have a run transaction, you want to take something out and then you want to call something, this is not enforced unless you are talking about the transaction is spending. It is spending because it is connecting these two. So that in that sense, it's kind of like a call another function. But if it's independent, I think that's something doing off-chain by some agent.
That makes sense.
Make sense?
That makes sense.
So
It was
think
one of those
about
comments that he makes where they kind of, it seemed like there was some magic in it that he wasn't giving us. So that would make more sense.
I think unless you want to do hard fork, right? The miners only take the locking, just unlock, just connect it, run it. That's it. That's no other thing. So think about this like a building block. So when you want to do like other even fancy stuff, you want to, okay, this contract and this transaction call some script in other transaction. Even you want that, you still need something how to handle the case within even a single transaction, right? You want to express some logic, right? So that's I could imagine that's something can be built on top of script. So script is kind of like a one layer on top of the script, and then that's the inter-transaction method invocation, whatever you call it. That's going to be even more one level even up. Make sense?
Yeah, it does.
Well, in theory, couldn't you chain two scripts together? I mean, that would just be one script,
Say
right?
that again?
Chain, like just add two scripts together, the syntax. So like if you just take something that's already on the chain, like you were saying, you would do it in an application. You would
Yes.
just load a transaction from some index
Yes.
and then just combine it with some other.
Yes.
But in your program, you would just reference that instead of rewriting the logic, if you see what I mean.
Yeah, it's like it's almost like a stored procedure, kind of like you are building a library. You store the code in some transaction, and then you kind of have some abstraction. So I want to call this function, but instead of doing like a RESTful or whatever, you just say this transaction ID or something.
Right.
Is that what you mean? Yeah, I can store some, let's say, gig or rock, whatever. You can store in some. That's pretty much what he meant, right? It
Yeah,
stores
I think
the
he's talking
logic.
about composing these together, where
Yeah.
you have, like, say, your Raven signature script,
Mhm.
and you want to combine that with a multi-sig version of that, and then you can combine them together in some way by referencing a script that already exists somewhere.
Oh, that's one way. So basically, if it's even not in a single transaction, right? That's one way. Another way you can think of, actually, yeah, I had it working, but it's not in IDE yet. So I have some background. Basically, I now have I can support library. So basically, let's say you write some fancy, very good optimized script code. You want to contribute to release as a library, and then somebody else can come here and just say it's like any other language, right? You can actually say it's not in this version here, but you can almost say, let's say, yeah, you can have something like that. Yeah, now it's here, but it's not on the web version yet. But it's handled. Basically, don't worry about it. It's like a basics. So yeah, you have something like this now. So yeah, to summarize, basically you want to call some other functions. And basically one way is to do it within. So basically you export it as a library, like a JavaScript or anything. Then you can import it. It's almost like you copy paste this code. But the compiler is going to do it for you, so you don't worry about it. So think about here. Then you have you can build all the frequently used common libraries. Right? For example, if somebody wants to use pay to public hash, there's no reason he has to write it himself, right? I mean, he can. I can show you, but he probably doesn't have to, because this is the number one contract ever. So think about the on-chain. I think the most. I haven't checked the statistics, but it's probably like I don't know, 50% of all the transactions that in this contract. So imagine I want to have, for example, I want to not only have to verify the hash and the signature checks. I want to say, for example, I have some for example, I have to need some R puzzle. You have to give me that solution. But you can just append it here, right? So it's like a JavaScript. You can compose it. You don't have to write everything from scratch. So later, when I release this thing, so hopefully this can become popular, so people can write shared libraries, right? So you write something, you want to upload it, and also even you can think about even longer term, right? It's like you have a GitHub, you could import some libraries here, or you can even monetize it, because now you are talking about Bitcoin, right? So you can say, if you import me one time, you pay me one Satoshi, something like that. But yes, so within a transaction, you can import the library, call other contracts, like object oriented, you can use other classes, and also that's can only like everything can be dealt with script. But if you want to call some across different transactions, that's one level up you have to build. Probably we will build some kind of like a SDK or something. You can easily reference code, like some kind of like a prop code, like a unwriter's prop code, maybe not for data, but maybe call different across transactions.
So I see how, I like this. I like how the IDE works. I think that's really cool. But if I wanted to build something to generate something unique on the fly, how would I deploy this into, say, a JavaScript app or something like that?
Okay, so for example, this one, right? Just give one example. There are two ways. The first way is very easy, and it's manual. What do? You copy
that.
this thing,
Yes.
you paste it into the output script, right? That's it.
But let's say that that's going to vary over time, and I'm not going to know until.
Yeah,
Okay.
that's another reason, right? So probably when you have a contract, you generate a lot of transactions. It's probably not the same, right? Exactly
Yes,
the same. You may
exactly.
want to customize. Let's say you want to pay to somebody's address, right? The address can change, right, over time. You can pay different people, or you are not reusing address, whatever, or you have changed address. So the way you do it is also on the background. I also have this SDK. So basically, it's like think of like a JavaScript binding for the compiler. So it basically says script.compile, and you give it source code, and then you give it this code. And then this code you can plug in, say initial, you plug in the runtime parameter, and then all the wrap things together, put in the output, and then put the output into the transaction, and then sign you can broadcast it.
Nice.
So everything you can do in manual, but also you have libraries, so you can.
So do you have the binding right now for JavaScript or any other languages?
I think not yet, but I hope that I can release it by CoinGeek.
Okay, good.
So, and that's one thing, the SDK bindings, and also that's one thing. I have the import, but now I'm actually building something like okay, just give you guys a teaser because you come all the way here. So basically, I have the building extension of the VS Code, so you can. It's not. I'm not going to show you the code, but basically you can open the script code, and then you can do everything, whatever I showed online in here.
Oh,
And
nice.
then you can also have testing framework. It's like think of you are debugging, you are developing JavaScript. You will have the same experience. So the only thing different is the syntax is a little bit. You may have loops, you may have public function, but the idea is you don't have to learn things new. You just, I even have a testing framework. It's almost like a Mocha or, it's as if you are developing in JavaScript. Make sense?
Yes.
Okay. Anything else?
So you're going to present that at CoinGeek?
I will apply whether they will accept me. So that's another. Yeah, if you guys can. Okay, just all add to Jimmy or shadows. That would be great.
I'm
Yeah,
expecting
yeah.
to see.
Yes, please. Okay, please. Anything else?
That's good.
Okay. I think that that's the one of the most interesting point I would say. And oh, by the way, because anyway I'm here, so I just show some example here. That's also. I just mentioned the website called script.studio. I'm going to show it later. So if you scroll down all the way, you also give you the link. So basically, that's a link. You can go to they can take you to the documents here. So basically, you can have all the language specifications. I have also list a few examples here. So basically, how you do I would imagine popular contracts and all the details. So if you just go to that side, and then you can go to the document side. I think I'm also going to post on the meetup page, so the references. I think it's already posted the language, yeah. So you can go there and then check it anytime. So coming back. Of course, I think I pretty much showed this earlier. But basically, another common language feature you have, you want to reuse code, right? So you have of course you have function. So basically, I give a very simple example here. I think it's pretty self-explanatory, so I don't need to talk much about it. So you can also show some demo here. So basically you have a function that computes the sum of two numbers. Not very sophisticated, but you get a sense. So again, still compile. And you can say two numbers, let's say 3, 6. Oh, by the way, that's how you do it. You delimit with a comma. You have multiple parameters to initialize it. So then you can plug the solution, of course, here, 9. And also going to walk through some the debugging features. Basically, this is all good, but what if you have some problem? You want to walk through the code and see how which step you make some mistakes, right? For example, here, let's say I put it 10, right? So you will, not surprisingly, you will fail. So what if you want to find it out? So you can set a breakpoint if you click on the left. So you can, for example, you enter debug mode. You can go to the breakpoint, and then you can not only look at the variable, what's on the chain on top of the stack, but you can also look at what are the watch variable names and the values. You can see what's going on. And you can also, of course, set another breakpoint here. You can keep continue. Oh, because now it's already finished here, so that's why it fails. So, any questions about the call function? This is like imagine not as surprising as loops.
What's the field size?
Say it again.
What's the field size? 32 bits, 4 bits? Are you just going to use like? So is it going to be arbitrary? Could it be like
Okay, good question. Yeah, good question. The answer is, for now, it's 32 bits. But after the Genesis, we're going to have big numbers. So that means you can put any arbitrary number there. So actually, the story is kind of funny. Yeah, it's when Satoshi first released it, it's 0.1. It's arbitrary, like you have big number, right? But then the core developer coming out, okay, it's too dangerous, guys. Let's disable it for whatever reason. It's now has been almost like, I don't know, 8, 9 years or even 10 years. It's been 32 bits. So one of the most exciting upgrade is coming to Genesis. It's going to remove that bug. So it will become unbounded, actually. So you can, I can play with it. So if you, for example, I compile the signature pay to public key hash. If I compile, if I come here, come to the debugging mode, actually, of course, this one I think, enlarge it, but anyway, let's shrink a little bit. So basically, when you are dealing with signatures, because then we are not talking about just some small number, right? So you can actually be quite long. So for example here, this one, let's say this is hash, so I can initialize. So when you think about the pay to public hash, right, the unique number should be a hash of the public key, right? So which is this? You can look at it here. So this is also, you can input the hex number. The only thing you prefix it with 0x, so meaning it's a hex. So you can also put quite big number here. So I think for now you can, if it's a hex, bytes, you can put, even after the upgrade, even for numbers, for example, integers, you can put any big numbers, because internally, it's just use big numbers, so it doesn't matter. Negative, positive, doesn't matter. You can put out any number. But for now, if you want to do like a multiplication, say some 2 keys, you have to almost write a function yourself. You are doing big number, but you are implement a big number library, so which is a hassle. So that's why, we need to upgrade. Okay.
In the Genesis upgrade, are there going to be other opcodes or other changes that are going to require changes in this?
Opcode, no. I think except one, I think the change in the op return, the meaning of op return. So because for now it's like a hack. Most people when they put data on chain, they put in the op return. So op return just basically says failed. Whatever, it's like a log that doesn't have a key. Right? So if you put there, it's there forever. Nobody can span it because this log doesn't have any key in the universe. Right? So, but that's not the original code. The original code means, okay, so if I hit op return, I will just return. It's like any other language, right? So when I say return, it doesn't fail. It doesn't immediately fail the program, right? So return now is like exit or error out, but they are going to change back to return. So imagine now if you want to put more data, it will be a little bit different how you put the data into the script. So instead of thinking of the op return, you can think of actually there's some opcode. It's called op push data. So that's originally that's the way how people put data on chain. So opcode was no, but the big thing about Genesis upgrade, the good thing is that uncapped, remove a lot of caps. So we all know about this block size cap, right? But there are a lot of other caps. For example, how long is the script? That's, for now, I think there's also some number. I forget, like 200 opcodes or something. And then they're also going to remove it. And also you have number of signature check operations you can have, and also remove it. And also the number, also the how long is the transaction size. Each transaction you're also going to remove it. So basically, and another big thing. So actually, if you want to put this on chain now, I don't think you can do it unless you have a direct connection to the miner, because there's a concept called standard transaction. So basically, there are only I think it's 5 types of contracts you can be relayed. So basically, if you put this, you send to some nodes. If it's not a miner, yeah, you will just be dropped because they're considered as like an attack vector by smart developers. Yeah. But after Genesis, you can. I think this is going to be relayed. Anything you put there is going to be relayed. Whether it's a mine or not depends on, of course, there will not be some artificial limits. It will be depend on the fee you pay, right? So then it's a peer-to-peer. Like you send a transaction, I'm a miner. Whether I mine or not depends on whether the fee you pay me is more than cover my cost, right? So then it will be determined by the market. So, but the bottom line is, at this moment, as we speak, before Genesis, you cannot easily put any kind of contracts on chain, because first you limit the number, the type of transactions, the contracts you can send on chain, but also if you're not standard, the standard also now you have caps, because I think 220 opcodes you can have. It's not you can write anything after it. So this is more, the full feature can only be realized after the upgrade. But for now you can play with it, but I would imagine it can explode. It's like when we release the op return level. This is even better version, because now not only you can put data on chain, you can also put a business logic on chain as well. The short answer is you cannot easily do it now unless you have direct connection to some miners. They will mine, because some people along the way they will drop it. But then after Genesis, because then this is considered anything is legit as long as you pay. So then you'll be much better position. And also the size limit is gone, so you can put anything there. Just pay sufficient fee. That's it. It doesn't have any other aspect that can limit you.
So how are you going to charge for this? How are you going to make money?
Okay, so first of all, I think this one I commit to make all this. Of course, this one is always free, because this is something I want to have people come and learn and play with it. I don't want to charge anything, but for it's a short story. It's like a freemium model. It's like a Visual Studio, right? So you have Visual Studio, like a community version, intelligent community edition, because you want people to pay. You don't want the people to pay to just learn. And then if you have advanced features,
Like binding, runtime.
that's one aspect. Another thing, big thing, think about it. So, okay, let me show you something. So, if I, for example, then you'll get a sense. So, for example, this is pay-to-public hash, right? But once I compile it, do you see some difference here? Did you notice this is not the exact opcode you are thinking about? It's usually like a opdupe of hash 160 and op equal, right? And the hash in between, and then checks it, because this is unoptimized version, right? Because this is like the basic idea. I want to get something working first, so people can play with it, and then I think a lot of difficulties, well, the challenge will be how do you optimize this thing, because you are paying for the size, right? So you want to optimize. This is like, if you can optimize this thing by half, you just almost cut your transaction by half. So I'm betting people they are willing to pay $5 to save $5,000. So it's like Visual Studio, right? You can use the free version or IntelliJ, but last time I checked, Microsoft and IntelliJ, they're still up. So yeah, that's one model. The freemium ID, yes.
Can you
But
use,
I'm going to give you guys free. So lifetime member for free.
can you use this to put arbitrary data in the script?
To
Arbitrary data.
Arbitrary? What do you mean?
So like how people are using op-return as a hat to put on data. Can you use this?
Oh yeah, that's even simpler, because first you can always put in op return. Just make sure you precede it with op force, because then you return and look at the force, it will be force. And also you can have okay, I'm going to have something like I think this is still have to be accepted, implement, but it will look something like almost like you will look something like this. Let's say SF meta. You see what I mean? So you are like output data, right? So whatever data you wanted to put it there, you just put it there, and then internally it will be like op pushed and op dropped. Yeah, you can, and it's even better because you don't have to write the manual. You can do whatever. You can do strings, you can do numbers, you can do Boolean variables. Yes.
When you started talking about loops and Turing completeness, you wondered if there were any BTC folks who might contest what you were saying. What did they say
It happened.
when you just show how obvious the unrolling is? How do they react?
Oh, yeah. Some people say I was funny story. I was Stefan from Unisoft. He invited me to video dive into some Norwegian SV meetup. Like it was like 20 minutes. Was all good, and then I went to the loop thing, and then there was one guy say, "Hey, you, this is not Turing complete." I said, "How?" And he said, "I had a PhD, so." I don't know how to respond, but I spent the next 15 minutes we are like arguing whether fake Toshi I tried to show him some papers. So basically, about funny story. I think Craig has 3 papers, right? This one titled Bitcoin Script is Turing complete. It's peer reviewed, double blind, except he's talking in some conference. And then I sent him. I said, okay, I have this article. I'm going to send it to you. And then even after we argued half an hour later, then offline I found through my documentation. So basically I'm going to do an advertisement here too. So basically you scroll all the way down, you can find my contact here. So he joined our Slack, and then he sent me some probably like a Greg style, like a Max Greg kind of style, saying these papers are all plagiarized. It's like a 98% plagiarized. I was saying, okay, how do you know? He said, I try to contact the publisher and the editors for the conference, and they all reject my claims. But I have this article on Medium.com. It must be true, so go read it. So the short story is, yeah, I haven't seen any very valid counter argument. I would say is the only thing I think they can bring up is. Yeah, I cannot think of that. Yeah, seriously. If you guys know any, just let me know. But I can put a challenge though. Just show me something, because I think in the computer science, I don't know, somehow in the textbook, usually when it says Turing complete, it's like you can solve the Harting problem somehow. Let's say you have an infinite loop, infinite tape, but he's saying, okay, why you have stack, right? So I think I showed you earlier. You have stack, so saying, oh, you cannot run infinite loop. I say there's no such thing as infinite loop except in theory, right? I mean, you have some servers, you have a big loop saying while true, but at the end of the day, someday the server is going to stop, right? And also the server is also bounded, the loop is bounded by the physics, right? It cannot run in any infinite loop. It's like a Ryan status. There's no things as infinite in reality, right? So I think that's the only argument I can see. They say you cannot do infinite loop. I was just saying, if it's infinite loop, it means you want to compute something that's never finished. It defeats the purpose of computation. The Turing complete, I think, in my understanding, I think it's correct, as Ryan's been talking, and I say, if you look at I haven't read it. They went to the Turing's original paper. Basically, it says that means it doesn't mean it's infinite loop. It means any number that's computable, I can compute it. Then it's Turing complete, right? Then it doesn't make sense to have something that never stops. Then why do you have the computation in the first place? Basically, anything you can compute, if I can compute, that's how you prove Turing complete is. Right? If already something I have Turing complete this, if I can say anything this can compute, I can compute, then I'm good, right? For all practical purpose, even for theoretical purpose, it's all good. I don't need infinite loop. And there's no such thing as infinite loop, because you run out of time or physics, memory or money. Even you write a while true, someday it's going to stop. Right?
I can see where someone might say, well, it's inefficient to iterate, to unwind 1,000 when you only need 10.
Okay.
I can see where that's inefficient.
Yeah, that's a good argument. So,
but I think if I understand what you said earlier about being able to bind into a language, then you could probably omit only the 5 that you need. Is that true?
Not really. So basically, because this thing has to be determined at compile time, so the maximum bound, you have to be very conservative, right? Because you don't know what's going to
In
happen.
the static version, when I copy it manually, I agree with you.
Mm-hmm.
But if I understood what you were saying earlier, where your scripts would vary, and you would want to generate them at runtime?
No. Basically, if
so
it varies,
Yeah.
then you put the upper bound. You take the maximum, because otherwise, you risk you will fail. The script will fail, because if you want to sum from 1 to 1,000, you only sum 500 times. You will not get the correct answer. But that problem is not going to be solved by the language, and you should not be solved. Should be solved by what? By the market. Because think about it, right? Because right now, the miners are not competing very much. Because think about it. I think that's a legit criticism. For example, right, if I want to compute some number from 1 to some number between 1 and 1,000, right? But then for my language, I always have to put 1,000. But somebody can only say, oh, I want to sum from 1 to 700. And then the rest 300 is wasted, right? And then you still have to pay, because the miners now charge based on the number of bytes. But think about this thing as the miners evolve, right? If I'm a miner, if that guy charging 1,000 satoshis for this script, for this transaction.
I understand.
I'm going to charge 800, right? I still profit. That guy cannot take, because if you pay 800, I can take it. I still earn 100 satoshi. Brandon does he's charging based on per bytes. He said, oh, this is below my free rate. I will refuse it. So if you see this competition, you will drive it so the margins getting smaller and smaller, almost to the cost of actually running. You see what I mean? So this problem, I think it's going to be solved by the market, but not by tech itself. Does that make sense?
Yeah, I was thinking something different though. Let me take one more pass at it. I don't want to spend any more time on it.
No, that's fine. Really,
But if you take that code that you have up there, the script code, you have a constant in there that determines how many times you're going to iterate, right?
Mhm.
Loop 3 in your other example. Well, what if I'm generating the script at runtime, I'm not pre-compiling it offline and just copying the string, then that number 3 doesn't have to be a constant. It could be a variable that gets expressed.
Okay, yes. I think now I understand what you're saying.
Yes.
That number is varied in the language
Yes.
binding, but
Yes.
not in script itself. It can be, for example, if a JavaScript binding, you can say, oh, this always is the input is square, let's
Yes.
say. So, but that square part is in the JavaScript code.
Yes.
But when you put here, when you compile down, you are going to still put the actually constant here, but it's just that const is in script, but this const is a variable in JavaScript.
Exactly.
Yeah.
And so when you get to that point, when you can do that at runtime, then a lot of the arguments about it's inefficient go away, because
Yeah.
you can size it just right for that
Yes,
transaction.
that's because this is the tool, right? How you optimize it is based on it's like writing code, right? I just give you JavaScript or give you C++. And how efficient is your program is up to you. I can optimize in my end, optimize to a certain extent, but most of the business logic, the efficiency, right, is coming from the developer who's writing the code, right?
Yeah.
Yeah, I agree. In that sense, yeah, it's dynamic. It's not constant in that language binding. Yes, it can.
So once you get that working, a demo that shows that the output is varying based on the transaction,
Yes.
that would quiet that BTC type of argument. Well,
I'm not
they'd find
confident
something
about
else.
that.
They'd find something else.
Yeah. They always move the goalposts. It's like,
Yeah.
hey, the SV you don't have minors.
Yeah, yeah.
Then we have minors.
Yeah, yeah.
You cannot have a no software. We have no software. Oh, then you cannot have whatever was the latest. You cannot have 1 terabyte.
Just
yeah.
like Craig moving keys, he stole them. I mean,
Yeah.
it's
He
stupid.
kidnapped. It's like. How do you win? It's always moving the goalposts. It's like you never catch it. But the good thing is, we just always take more territory each
Yeah.
step. So you may never catch them, but they will just go to infinitesimal small. It's like we're always expanding, they're always shrinking. So they will be there, but it doesn't matter. It's like you have Facebook, you have Google, you have other competitors, but it's almost non-existent, right? So, any other question or any comments?
I have a question. So
Yes.
we've looked at some moderately simple and some medium complexity here.
Mhm.
But I saw in your docs that you had Raven signatures.
Mhm.
Can you talk about what are some of the more complex types of scripts you might want to write where having a tool like script becomes really important? And I would imagine Raven signatures are one, but what else do you think would be?
Okay, that's a very good question. That's what I've been thinking about it. So, because now we have this tooling, but the problem is now we have the tool. But how do you, what kind of use case or what kind of examples you want to have, right? So, I think I would say one thing is pretty much any kind of a contract. Once the Genesis is over, the upgraded, I think we need to have two. I think for me at least, unless you are writing very, very simple contracts, you may want to get away around it just by writing script itself. but that's going to be rare. And arbitrary ones, I would think is like, I think here I give some examples here. I think some other thing I can think of is, one thing I really think about is like gaming. So basically think about the gaming, but without the middleman. So for example, we throw some dice, we play some paper, scissors, rocks, but nobody can cheat. So for example, right? So let's say, give one very hypothetical example, like a dealer is poker or betting. So for example, you say, you and me bet, right? But the usual problem is, okay, first, I can always cheat, right? So for example, if it's not on chain, I can always refuse to pay, right? For example. And then one example I have in mind now is, for example, you give me your number, you commit a hash, and then lock some coins. I commit mine, also lock some coins. And then how do you decide who win? We take the XOR, right? For example, that one, I think it's not a few opcodes you can solve that. It probably is much in here. You only a few lines. Okay, this hash, you hash this perimeter equals to this target, and then you do the XOR. If it's say odd, you win. If it's even, I win. That's one example. I think the bottom line is, yeah. So this is like a tool. Then how people are using, I think that's is like unbounded. It's not. I cannot think of all the use cases. I'm just thinking it will be a lot of people will try and play with. It's like an operator. Now it's suddenly opened. Now it's another dimension. You can have all this upstream contract. I think, the easy low-hanging fruit, the pot, some other contract from some other chains which are popular. So that's my starting point. I would think about it, like, I don't know, CryptoKitties or the FOMO or gaming. That's one thing I think about. I think some other people are saying, been talking to a few people that are talking about kind of like a insurance contract. For example, you have some kind of oracle that can sign a weather, or you can flight delayed, and then you can pay a certain percentage, or some even supply chain. You like have your own chain, and everything is locked up in a contract. And as long as if I'm a consumer, I buy some Norwegian salmon, I sign and pay, and then everybody can unlock the payment instantly. Distributors, fishermen, truck driver. Yeah, that's another example. I think for that case, yeah, it's hard to be just write a script directly. I think if it's ASCII, you can use it to, does this guy match this signature that he signed, and then if this sign, I release some, I don't know, pre-image, and then the upstream guy, they can sign, and then just cascade up.
Well, kind of in that answer, if you find a coin somewhere on the blockchain, and let's say you think it's yours, but the script is,
Okay.
a megabyte big or
Yeah,
something.
I see where you're going.
How do can you map that back to the script code to know that this is,
Yeah, disassembler. I think you can do that to an extent, I would say. I don't know if it's theoretically.
or if you have the script code that it might be, can you compare it to see that that is what it is?
I think you can. Let me think about it. I think if you have the opcode, you can reverse it to at least functionally equivalent program. You may not know the original program. It's like you go to Etherscan. I think there you have to submit the source code. I don't think they are de-assembly. I think at least you can do it to an extent. It's like you are reverse engineering the thing. You can map it back, but it's a functional equivalent, and not be the source code may not be the program.
Yeah, you won't
may
get
not
the
be-
clean variable names and all
Yeah,
that
yeah,
sort of
yeah.
stuff, because
You
those all
can-
disappear.
Yes.
But you would still get something interesting.
But let's say
Yes.
you had the Raven signature contract for
Mhm.
script right here,
Mhm.
and then you had a coin that just had all the opcodes. Could you know that coin used that script?
I think.
Like if you have the raw opcodes, can you make sure that is what the script code is?
I think at least for popular ones, that which have templates, you can, of course, it's like some, if I now go to any Bitcoin Explorer, they let me see the login script. If I look at the dupe of 160 of, that's a pay to public hash, right? It will be something like that. And also So first point, if it's like a very popular one, you can easily like deassemble it. And second one, I think even in theory you can deassemble it, because this is almost like, if you know the opcode, it's pretty much you know all the logic, right? You get it functionally equivalent, something you can compile down to it. I think yes, you can think, but as he was saying, you cannot get the exact same copy, but you can get a functional equivalent. Yes, but I would imagine that would be fun. You can have some deassembler, because then you are having an advantage, because you know what this contract is doing, right? Because nobody's going to look at the opcode for this contract, I'm pretty sure, unless you are like N-Chain, I don't know, a crack or Steve. You probably can figure out, okay, this is the, I can see the wrapping signature. Let me find some clues and
Well, I'll
claim
throw out
the
an
money.
idea for you. One thing you could think about doing was if you put the script code on chain in an op return somewhere.
Yeah, that
And
could
then
be also. Yeah.
As the first couple opcodes in your script, you pushed and then dropped the location for the script code. Then you could know,
Yes,
what
that's,
code you're doing.
yeah, it's like Etherscan. When you submit your contract, you have an option to put your source code there.
Mhm.
And then how do they verify? They have a compiler, you compile and then exactly match, then it's verified. Yeah, I could imagine you can do something similar in like a blog.
That's kind of a
Explorer.
library too.
Yeah.
Yeah,
Yeah,
you
that
can.
would be good. That would be a solution. Part of the solution for the library, reusable code where the library is actually on the chain.
Yeah, you can.
And
That's
you
one
can
way
write
to
it.
distribute it. Then
And
you
you
don't
can
rely
write it.
on GitHub. Right?
Yes.
And also you can encrypt it and even sell it.
Yeah.
Yeah. Then the operator is like, this source code is data, just data. Right.
Right, exactly.
So, yeah. You can compile it to script and then put it as code. You can also take the source code and then put it on chain. But then I could imagine you can also have like a Etherscan and say, does this match? But then the problem now, because we have multiple outputs, we are not like an account-based system. You can say, this is the output 0, this is the script, and then I can certify this is my source code because I can compile and match, right? So that's one way. I think the other way I always have in mind is that when you put a contract on chain, right? I could imagine there are some cases you want like a privacy. Maybe you are dealing with just your supplier or something. You only want each other to know, right? That's of course. But there are also some other, like a public contract. It's like you are doing mining, right? I don't care who you are. You just find me this hash. It's 100 leading hash. I don't know. I don't care who you are, and it's like a public boundary. But that kind of contract, I would think of that would be like a registry, kind of like a NPM app, or GitHub, or like an app store. Like it's a contract store. These are all the unclaimed. This is contract. Okay, if you can find this solution, you can take the money. You can say, okay, these are all the on the contract, and then you can match people who can solve this. It's like a DAO. Yeah, I don't want to use the word, but literally you can outsource the stuff. If you can express your logic into the contract, and then you put money there, right? Then people don't have trust. Right? You find a solution, you take the money. It's atomic swap. That's one benefit I could say. Why something be better on chain? Because you don't need trust. And again, right? If I pay you, you don't give me the goods. If I give you the goods, you don't pay me. Then if everything is on chain, especially if it's digital, I would imagine this can be something fun to think about. I could imagine that there's going to be some like a centralized registry where you list all the unfulfilled contracts, and then which with boundaries. These are like you are outsourcing your tasks, like a task rabbit that is on chain. It's just think about it. It's a lot. It's literally unbounded. So the limitation is on your imagination. So just play with it. I think a lot of it's hard for myself to imagine what kind of things people are going to build. That's an interesting part. You don't know. I think some people will play with it, and you may build some apps and then embed it. That would be like great.
Are you doing this all by yourself, or have you got other people working with you?
Mostly myself, except the UI stuff. So I'm more like a back-end infrastructure. So for this this is the version 2. I don't know anybody has. Oh, probably not. You can, if you join my Slack channel, there's some like snapshot of the first version, which is functional. It's not looking great. So I have my friend is actually he just joined me to work on this together. The person is kind of like more full stack than me. I'm more like a back end kind of guy. So yeah, but to your question, yeah, you learn JavaScript, then you can do both. So you can do everything. And its syntax is also similar to Escript. So yeah.
Why did you choose the name Escript?
Oh, that's okay. Anybody have guess?
Simple?
Oh, what?
Simple?
Satoshi
It's kind of a combination of scripting and crypt, like as in cryptography. So you merge the words.
That's one. Yeah, that's one. That's 50% of the reason. Yes. Anybody else?
Before nChain existed, it was encrypted.
Yes. So that's the rest of the puzzle. So basically, it's a script, sounding like, because it's compiled to script, right? And also before nChain, the original, the forerunner of nChain is called encrypt, and now it's called nChain, right? So I want to follow the naming to be. It's like it's almost like a domain. Now you want to claim it, the A-crypt or A-chain, whatever. just don't issue an ICO. Yeah. Or I can buy it. Yeah. So yes, 50% is script and encrypt. So.
Have you started building apps with it?
No, not yet, because apps, I think I probably have some like demo apps, because I want to showcase how do you use it, how do you integrate it into your existing app. But I think app is like, I'm developing the tools, and my hope is so other developers, they can use my tool to build their apps much easier.
Are you looking to partner with anyone who wants to do that?
Oh yeah, anybody. Yeah,
So-
it's like,
So I mean, I'm guessing that anyone who wants, let's say that once you get the runtime binding done, I'm guessing that the first few users of that are going to take some time to figure it out, and they're going to have a lot of feedback for you.
yes.
So I'm thinking some sort of a tight relationship there would be useful. Where
Yeah, I'm welcoming anybody who's interested. You can always join my Slack channel. I think a number of people there are super active. I think they're trying. I think one guy, Stas from Israel, he's trying to play with this thing to do some R puzzle. So basically, you can now very easily write R puzzle in script. I mean, it's not easy. So the guy's playing. And of course, nChain. I mean, always talking with nChain. So. What else? I think Mempool. I think that they're always the forefront of the latest thing. So I think I'm talking with them because I probably have some non-standard thing before the Genesis sent to them. So hopefully they can help them in mind. And they're trying to do some kind of actually the game trustless the betting is one idea they I've been talking with them. Yeah. Yeah, the bottom line is if anybody's interested, whether you are doing this for for fun or even for a business, just always join the Slack channel or just ping me. We can always talk. And this is because this is something new. I think we're all, even for me, I think everybody's a learning process. Every day is a learning process. So if you say, okay, Ron or Geek, they want to integrate this, just always reach out.
Do you have libraries planned already?
Yes, I think I'm going to release something by CoinGate, the next CoinGate. So have the library and also have the desktop ID. So basically, you can just install a plugin. You can. That's it. It's like.
Is it like a standard library or somewhere?
Standard library? What do you mean? It's like any other kind of like a JavaScript library, like a BSV or Manibot or Express. Yeah, it will be like an npm package. You can npm install a script. That's it. Then you can use it compile and then compose the transaction. Once you have transaction, like any other transaction, like you can sign it, you can broadcast, you can change it, you do whatever you want. Yeah, it will be like a npm package. Okay. Anything else? Okay. Applause.